Hello, this is AP Computer Science. I'm John Maxwell. In this session, we'll cover all manner of methods. Method is the basis of communication within the Java software system. And we'll find there are many applications and many different types of methods. So let's get a start. What we're looking at here is a method header or a method signature. It consists of four different parts. First off is the modifier public. It's sometimes called the scope access modifier, but it determines that this function can be used outside the class, and that's simply what it stands for. Later on in this unit, in the future, you'll see the modifier private, which means it cannot be accessed outside the class. It can only be used internally. So, not too much about the modifier. At the end of a function's execution, what would be called the method body in between the two braces, if a return type is specified, then there must be a return statement, as you can see in the example before you. In this case, the return type is a double, which is the result of width times height, width and height being doubles. So a return type can be specified. Sometimes the return type can be void, in which you wouldn't really expect a return statement inside the method. The method name is fairly straightforward. By convention, it starts with a lowercase letter, and it may have a capital letter further on to clarify or for readability. Get area with a capital A allows the reader to see two words there, and but by convention it begins with a lowercase letter. And finally, in between parentheses are parameters. Also can be no parameters and just empty parentheses. We'll see an example of that later on. But the parameter list is marked by both type and the name of the variable. So double width, double height. So if you try to call that method get area with two ints, you would have an error. So it specifies or requires that you have two doubles in order to call this method. Well, what's so important about methods? In method, you have a mechanism for communication. In come the parameters, out goes the return type. And so the software system, which in many instances can be quite large, figure like the old example of Amazon, in order to communicate to different parts of that system, shipping, billing, product, inventory, etc., you would need to pass information along so that other classes perhaps could deal with it. For example, when a sale is made, it would return the product to the shipping department so it can be picked and shipped. So there's an example of communication. It usually parallels the way the organization operates. So it's vital, and I can put it down in one sentence. The art of programming is the passing of messages to and from different parts of the software system. The art of programming is the passing of messages to and from different parts of the software system. And indeed, this is achieved through parameters and return types in part. We'll see it another way that you may be able to communicate or report changes in one part of the software, but we'll deal with that in the future. So I'm going to switch over to some concrete examples, and I'll share the link for this graphic in my communication to the students. So here we have like a simple program such as we've worked with, not that program, but this one, okay? We have a main class, I'm sorry, a multiply divide ints class with a main method. So the main method signature is pretty standard, but now you know it returns nothing and takes a string arg square brace argument. Begins off input two integers, and you can see that multiply a b, okay, is going to take two ints and return the two ints multiplied against each other. So here's an example of a method that has a return type int and two parameters, which are both ints. Note when it's called on variables a and b, but around this town here in multiply, they're known as x and y. The values get transferred over from a into x and b into y. And we also have a local variable m. You don't have to do it this way. You could just return x times y, but I'm being more explicit here and telling you that m is a local variable that's been declared within the method body. And after the method finishes execution, m gets removed from memory. It cannot be accessed outside the method. Let's talk about the scope, which is the range in which a variable can be used. The scope is dictated by where it's declared. So if it's declared in a method body, such as the opening and closing braces, it can only be used there. Even x and y, which have the values of a and b transferred in, passed by value, x and y will expire upon the finishing of the program. So here we have divide, and I did a little trick there. I cast x as a double and then divided it by y, so I would get a double return, and that would be indicated by the return type here. Again, a and b become x and y. And print them down here is a void method. It doesn't return anything, it simply prints out the values that have been received, A, B, C, and D. And so let's run this for a second and we'll just input some values when it runs. Well, here it's asking to input two values, 12 and 5. And the result is 12 times 5 is 60. 12 divided by 5 is 2.4. The integer result of division is 12 divided by 5 is equal to 2. So want to point out here how I got the 2. I didn't need to call the divide method again. I simply needed to cast d as an int. And when you cast a double as an int, you remove any element past the decimal point and including the decimal point. So that's how I got from 2.4 to 2. And if you want to call it round down, you can, but like basically the term for it is truncate. So this is an example of a method within a class. You define it outside the main method in its own space, and you can use it anywhere from within the main method, or in fact, one of these divide could call multiply if that applied. So one function can call the other. And that is a pretty standard way and is what is required of you for the assignments this week. Let's shift away to math.static. And I asked the class last night, what's missing from this class? Take a look. And they replied a main method. So since main is the starting point for the software system, the compiler looks for a program with a main in it in order to run. There is no main, so this can't be run. And all the methods are static, just like they are in the other context. So we have subtract, add, multiply, float division, integer division. The only thing that perhaps is interesting about this is, remember I said one function can call another in the class? The int division calls the float division, gets a result, and then casts it as an int, which truncates it, or if you prefer, round down. Okay. Well, this is very good, but without a main method, it really can't run. So here's what's going on. In another class, math static test, I asked to input two integers. And notice I can call the add method in the static class by using the class name. It's an important distinction because normally a method is called either within the class or by an object of that type. So when we had like a string called name, we had to do name.substring, name.length, name.indexOf. It had to be an object of the type of the class, in that case string. But with static methods here, this is what static means, or effectively results in. It can be called by the class name. And so now you have the reasoning behind math.pow and math.round and math.square root. These can be called by the class name. In that case, math. In this case, math static. I'll run it. I used my two favorite integers today, 12 and 5. And it works, right? Multiplication, addition, scroll up a little bit, 12. Addition, 17, subtraction. Does the work, right? By the way, there's one method I didn't show you down here. It was out of view. It was the remainder, returns A modulus B. Remember, the modulus operator indicates what is remaining of integer division, and it only applies to integer division. So that's some example of a static method that can be used outside the class by calling that method with the class name. And that goes a little bit to understanding static. So let's look at something else. I kind of serendipity created a class called Scooby-Doo. And Scooby-Doo is like a abstraction of the real Scooby-Doo. So I boiled down Scooby to just biscuits. How many biscuits has he eaten? We know Scooby-Doo has a big personality, and if I was developing Scooby as a player in a game, I might have health, and I might have avatar, and I may have other properties to describe Scooby-Doo, but in this case it's just biscuits. You'll notice the word private here, which means that it cannot be used outside the class, can't be accessed. I asked the class last night, what's different about this signature, this method signature, also method header? And they replied it had no return type, which makes it a special type of method called a constructor method. And basically what it does when I want to create a Scooby-Doo object, and I do so in another class, which I'll show you in a second, this is the method that gets the job done. It puts that Scooby-Doo reference in memory. I'm going to pause it for a second while I clear my throat. Okay, here we go again. Cleared my throat. Anyways, we were talking about the constructor here. People noticed that there was no return type because essentially the return type of a constructor method is the object itself. So if I go to Scooby-Doo game, here's where I create a Scooby-Doo object. The constructor's called with a new keyword here. And biscuits here, which I've entered in from the keyboard, becomes B here. The value gets transferred to the constructor method, and the private instance variable biscuits declared on line 3 is assigned the value in B. Now, like any good dog, they like to get fed. So here's feed. It doesn't return anything, it's a void, but it takes in a B and adds it to the existing number of biscuits plus equal, which means, hey, add B to biscuits. Now, get biscuits, and by the way, that is a modifier method because it changes the state of the object. And the state of Scooby-Doo, or the properties of Scooby-Doo, are maintained in just one instance variable, biscuits, but as I referred, state could be a lot more complicated for other objects. If I made a real Scooby-Doo, it might have the avatar and health and all the other Scooby properties that you'd want to capture in a class. But feed is a way of telling Scooby-Doo object to change, to add B to biscuits. Get biscuits is known as an accessor method because what happens is you just return biscuits. Somebody wants to know, I'll let you know. I'll return biscuits. A modifier typically has a void return, while an accessor has an int. We also have another feed, which is taking a double, overloaded method, okay? And by the way, since Scooby can't eat a half a biscuit, he'll choke. I've converted it to an int, and it needs to be converted to an int because notice biscuits is an int, so you can't add a double to an int. So I cast B first and then add it to biscuits. He loses out on a half a biscuit, I suppose. But notice it has the same name as the other method. But it differs based on the parameters, what's in between the parentheses. This is known as an overloaded method because it has the same name but different number, order, or types of parameters. So that's the definition of overloading. And you found that in the string class when we work with the substring, one that went from beginning index to end index, and another that just started at an index and went to the end of the string. So substring is an example of an overloaded method, which is a method with the same name but different number, order, or types of parameters. By the way, although it happens to be that both these methods have a void return, you do not have an overloaded method when you have a different return type with the same number type and order of the parameters, because the computer will error out. That's not how you overload a method, by return type. You overload it by parameters. We also have a accessor method here, returns row, and a modifier which sets biscuits to 0, because when Scooby's scared, he loses his biscuits. Bad joke. Let's see how to use the Scooby class. By the way, this is not runnable. This has no main method. It's a blueprint for multiple Scooby-Doos. So if I wanted to use this blueprint in episode 1, episode 2, episode 3, I could. So I could create a different instance in every episode. But I already talked about creating an instance of the Scooby-Doo class. I called it dog. Scooby-Doo new Scooby-Doo creates a Scooby-Doo. And then I say, Scooby-Doo has get biscuits, dog.getBiscuits. So let's talk about dog. We talked about like name.substring, name.index. This is known as the implicit parameter, the one on the left-hand side of the dot, okay? Let's review a little bit. Over here, we could just call divide without anything, no dot multiply or divide dot, because they were in the same class. They don't have to go looking to see where they are, okay? And in math.static, we were able to call using the class name. So we did go looking for math.static. We found one and everything was cool. Okay. Over here in Scooby-Doo game, we have to create an instance of dog in order to get biscuits. So it's object method, and it will return the number of biscuits. And now we feed him some more. Dog.feed the biscuits. And then we print out how many biscuits he has. We say he's in trouble, and then he speaks ruh-roh, and he gets scared. Okay, so let's check it out. How many biscuits do you want Scooby-Doo to have at the start? Let's call the constructor with 5. Scooby-Doo has 5 biscuits, so obviously we set the instance variable in the Scooby-Doo class to 5, and we were able to report it by calling the get biscuits method. Okay, we want to feed him more, 12. It's 17 biscuits. It looks like he's in trouble. Ruh-roh, Scooby-Doo has 0 biscuits. So when Scooby-Doo is scared, dog.scared, he sets his biscuit value to 0, okay, and reports that. The only thing that's interesting about this is this try and catch. You don't have to know try and catch, but I wanted a little thread sleep. After looks like he's in trouble, we waited 2 seconds, and then he said ruh-roh. What we do is we try to sleep the thread. Millis is computer time, millionth of a second, so 2,000 thousandths of a second. Correction. So 2,000 milliseconds is 2 seconds. Okay, so 1,000 milliseconds is a second. And we don't do anything if it couldn't sleep. We don't predict that it could have a problem, but with a try, we have to have a catch. You don't have to know try catch. So that was so satisfying. Let's run it again. Okay. How many biscuits do you have at the start? 5. Oops, I typed it up there. Bad me. 5. How many do I want to feed him now? 12. Uh-oh, he's in trouble. 2 seconds. Ruh-roh. Okay, so you'll get to see if you want to put a pause in the program or not. You can try this little try and catch switch. I think I deleted it. Control Z. Let's see, Control Z. Yeah, I deleted it by typing 5. So today we've learned about methods. Methods that are declared within the same class can be used pretty easily, like the first example, multiply and divide. Talked about by the way, actual parameters, formal parameters. Actual are the ones that are put in, and the call. This is called a call, multiply A, comma B. And the formal parameters are what's accepted, the values being transferred over. So we talked about using methods within class. Nothing really special. We've done this. We began to talk about static methods being able to be called by the class name, a big advantage. We gave some examples with math. And then we developed a Scooby-Doo object class, a blueprint for any Scooby-Doo we wanted to create. It had an instance variable, which is private, and a number of methods to construct, modify, and access information. We briefly covered overloaded, which we'll do again. But We saw in this example that dog, an object of the type Scooby-Doo, would be necessary to create in order to call any of the Scooby-Doo methods. So this is my discussion of methods. I hope you find it, useful. Good luck. Reach out if you have any issues.